Happy June, everyone. Today we're going to look at systems of equations. A system of equations is really just two or more equations. And in 7th grade, we're just going to look at our linear equations in a system. Here we're asked to determine the solution to the following system, y equals 3x and y equals x plus 8. And we're told find an ordered pair that is a solution to both equations. When we're talking about a solution to a system, that's one singular ordered pair that works for both equations. And we're going to go through a couple of methods to do this. Our lesson today is really using a graphic method, but in our Do Now, I want to show some other methods. So one thing we could do is think about our equation as a system of values, one for each. And what we're going to do is look for when the x's and y's match up. So maybe I'll start with an x of 1. So here, x of 1, our y is going to be 3. X of 1, our y is going to be 9. X of 2, our y will be 6. X of 2, our y would be 10. I'm just in my head substituting in. X of 3, our y would be 9. X of 3, our y would be 11. X of 4, our y would be 12. X of 4, the y would be 12. So there we have it. There's our solution. So we would say that the ordered pair for 12 is a solution to the system. Okay, so that's one way, sort of our table method. There is another way to go about this. Okay, it's called the substitution method. And maybe I'll write that up here, substitution. And you're going to do a lot more of this substitution method in 8th grade. So we take our two equations. Okay, and what I want to notice is both equations have these y's. They're y equal to's. Now this equation is stating that y is equal to 3x. Well, this equation has a y. Well, if y is equal to 3x, that must mean instead of writing y here, I could just substitute in 3x. When I do that, now I have an equation with just one variable, and we can solve for that variable x. So we get 2x equals 8. Divide both sides by 2. There we go. There's x equals 4. Now the next step, I'm just going to take that x equals 4 and substitute it back in to one of my equations. I'm going to choose y equals 3x. So x equals 4. I'm just going to substitute that into x here so I can solve for y. So that's going to be y equals 3 times 4. Y equals 12. So now we can see our ordered pair for 12. So that's just a little snippet into our systems. Like I said, in 7th grade, we're just going to worry about graphing, but I just wanted to show you those other options. One of the great things about systems of equations is that we can use them to solve real-world scenarios with two unknowns, two variables. And I think this is a great scenario where we see a system of equation of value as well as standard form of equation as being valuable. And I really saw this in real life when I went to a Yankee game and was buying hot dogs and sodas. So here's my problem. Alex and Mike went to a Yankees game. Alex bought 5 hot dogs and 3 sodas for $29. Mike bought 2 hot dogs and 6 sodas for $26. How much was the price of each hot dog and each soda? So we have two unknowns. Okay? So we let one, the price of the hot dog, be X. And the other, the price of the soda, be Y. And with Alex and Mike, we have two different scenarios that we can build equations for. So here we have our first equation, Alex's equation, that he buys 5 hot dogs and 3 sodas and spends $29. And then Mike's equation, that he buys 2 hot dogs and 6 sodas and spends $26. So now what we can do is we can go to Desmos, where we can graph our equations, and we can graph on Desmos in standard form, which is really cool. So there's Alex's equation and Mike's equation. We graph them and we find the point where the two lines intersect, the point 4, 3, where x is 4 and y is 3. That tells me the cost of a hot dog was $4 and the cost of a soda was $3. Okay, so now we're going to go into our booklet and practice our graphing our systems of equations using the graphing method by hand. We're on page 33. We're going to graph our systems of linear equations. We know the systems are two or more equations, that the ordered pair, their point of intersection, is a solution. Something we want to point out, that if there is no intersection point, then we say there is no solution to the system. But the only time we have no intersection point is when we have parallel lines, okay, where we see that same slope. Otherwise, we should see a point of intersection. Because we're graphing by hand, that point of intersection should be visible on our coordinate plane and should hit a perfect corner on our graph. So we should have an integer for both the x and the y coordinate. Okay, so we're going to graph each of these equations and find the solution by finding their point of intersection. So first thing we need to do, 2x plus 2y equals 8 is not in slope-intercept form, so let's solve for y in terms of x. Subtract 2x from both sides. Okay. So we get 2y equals negative 2x plus 8. We'll divide both sides by 2. Y equals negative x plus 4. I'm just going to kind of box myself for that so I know that's my equation I'm graphing. From this, I want to realize the slope is negative 1, if we think of it as a fraction, negative 1 over 1, and that our y-intercept is 4. So our starting point on the y-axis will be 4. Our slope of negative 1 tells us go down 1 to the right 1, right? Rise over 1, down 1 to the right 1, and we do that till we run out of room. Plotting each point. It's very important we plot each point until we run out of room, then go back to our y-intercept and use our reverse directions, which would be up 1 to the left 1. Okay. Now we'll connect our points with a line. Our graphing is even more important now that we're graphing 2. Notice I'm putting arrows on the end of the line and I'm going to label it with its equation. You must do that. If on Friday on our test you don't put arrows and you don't label the line with the equation, you're going to lose points. And that's silly points to lose. Okay. Now we have our equation y equals 2x minus 5. It's in slope-intercept form, which is awesome. So I'm just going to identify our slope, which is 2, if I think of that as a fraction, 2 over 1. And our y-intercept, which is negative 5. I can already see, since they don't have the same slope, they're not going to be parallel, so they should intersect somewhere. Even if I did see that they were parallel, I could answer no solution, but then we would also graph. So our y-intercept is negative 5. We'll start right there. And our slope tells us goes up 2 to the right 1. And we do that until we run out of room. Go back to our y-intercept, use our reverse directions, down 2 to the left 1. Now I'll take my ruler, create our line. Like I said, arrows on both ends, label with the equation. Okay? Now we graphed correctly, we solved for y in terms of x correctly. I can tell that because I see that perfect intersection point that I can name. So now I'm going to look at that perfect intersection point. It's the ordered pair 3, 1, and I'm going to label it and then write that down here as our answer. That's the solution to the system, the ordered pair 3, 1. If after I graph, that intersection point isn't perfectly in the corner of a grid box where I can name it, I did something wrong. Either I graphed incorrectly or I solved my equation into slope-intercept form incorrectly, and I would have to go back and check my work. Okay, so that's really all we're doing here today. If we look at our classwork on pages 34 and 35, okay, we will at some point, I hope, run into an equation where maybe they're parallel. Like I said, if you do that, you're going to write no solution, but still please graph. Okay? Something you want to notice on number 2 is we have that horizontal line. So we're getting a little practice there, graphing our horizontal lines again. So it should be good. All right. Tomorrow, our review sheet is going to be available on Google Classroom, and that will be due Thursday by 9 o'clock. Just a reminder, we have our graphing linear equations test Friday. Today's math jokes for mathy folks. Why was the equal sign so humble? Because she knew she wasn't greater or less than anyone else. Have a great day, guys.